In this video, I'm going to go over how to draw those structures for covalent molecules. There are some guidelines written here that I'll show you an example of on the next page. What's written under that, where the bullet points are, that would be very valuable for you to remember. Hydrogen has a tendency to make one bond. They're always found on the outside of the molecule. The reason for that is hydrogen has one valence electron that is able to share with another atom. The halogens, so for example, fluorine, they also only make one bond, and the reason for that is because they have these 6 electrons, these 3 pairs. They're not available for sharing. They're already paired up, but this one that's by itself can be shared with something. So they will always be found on the outside of the molecule. They only make a bond with this one unshared electron here, and then they'll always have, for us, they'll always have these 3 unshared pair of electrons around them. Oxygen is going to make 2 bonds. Oxygen has 6 valence electrons, so it looks something like that. Again, these 2 pair are not available for pairing off or sharing with another atom, but these 2 are. The nitrogen family will make 3 bonds. Again, this pair is not available for sharing, but these 3 are. And then carbon is going to, you can think about carbon kind of looking like that. It has 4 electrons that it can share with another element, or 4 different elements, however it may be. Remember that octet rule, and I use the word rule kind of lightly. Everything has a tendency to bond to get that stable octet, that filled outer shell. Hydrogen being the only exception at this point because it can only hold at most 2 electrons. So what those guidelines went through, if we look at the example for C2H5Cl, if you break that compound down and write how many elements you have, and what you want to do is write how many valence electrons those elements have. You can write down how many valence electrons they want, right? I'll kind of put one in quotes here. It's what they have a tendency to do. Carbon tends to bond with other elements to get that stable octet, which is 8. And everything's going to be 8 with the exception of hydrogens. They only have enough room for 2 electrons in their outermost energy level because they only have that first energy level, and that first energy level can only hold at most 2. So the need is you're basically just subtracting how much they want minus how much they have. So it's how many more do they need to get. And you can add these up. So you get 8, 9, 10, 11, 12, 13, 14. Since a covalent bond is a sharing of electrons, what you do is you divide by 2, and it's going to tell you there's going to be 7 bonds in this compound. Now, you're not always going to have to do this. I'll just show it for this one. So for carbon, for example, if we drew the structure for carbon, we want to put that down first because it forms the most bonds, so that's going to be in the middle. And now I'll put the other carbon in blue, and that has 4 valence electrons. And what happens here is you end up getting a bond here because it's a sharing of 2 electrons. Now the hydrogens, they supply 1 valence electron, and you get a bond formed here. And we have 2 more hydrogens, so we can put them here and here, although you do have some leeway in where you can put these things. And now the last one, we can do chlorine. Chlorine has 7 valence electrons, and then you get a bond formed there. So when you look at this, we did the math and it came up with 7 bonds. So you have 1, 2, 3, 4, 5, 6, 7. When you are done one of these problems, it's easy to double check your work. And remember what was the bullet points on the last page. How many bonds these things make. We said carbon is going to have a tendency to make 4 bonds. So when you look at this left carbon here, it has 1, 2, 3, 4 bonds. This carbon on the right has 1, 2, 3, 4 bonds. The chlorine has 1 bond, and it has these 3 unshared pair of electrons. Hydrogens will only ever make 1 bond. Now you want to check to make sure that octet rule is satisfied for these things. So for this carbon, each of these dashes counts as 2 electrons because the hydrogen was supplying an electron and this carbon was supplying an electron. So for this left carbon, what you have is 2, 4, 6, 8. So that one's happy. Now for this carbon, you have 2, 4, 6, 8. So that carbon has a stable octet. For the chlorine, you have 2 electrons here, so 2, 4, 6, 8. That has its octet fulfilled. And remember, hydrogen is the one exception. 1 bond is all it's going to get. You'll never have unshared pair of electrons around the hydrogen when it's in a bond. It has 2 electrons, and that's all it can hold. So if you want to, you can go through the math for that stuff, but I think what you'll see is once you get into writing these things, you probably won't have to. So CH4, for example, methane. We know carbon is going to make 4 bonds. So I'll write that down first. And I will put 4 bonds coming from it. And there's 4 hydrogens. So this one's pretty straightforward. We can draw it like that. Double check to see if you have to put in any unshared pair of electrons. The carbon has 2, 4, 6, 8. So it's not going to get any unshared pair of electrons. The hydrogens all have 1 bond, and that's all they can hold. So that one's good. Now, sulfur, for example, it is in the same column as oxygen. It has 6 valence electrons, so you get something like that. Now there's 2 hydrogens, so we'll put 1 on this side, and we can put 1 on this side, and they form a bond there. Now when you look at sulfur, what you have is 2, 4, 6, 8. It has the octet. Hydrogen makes 1 bond, and that's all it's ever going to do. If you did the math for this, what you would see is that it was going to form 2 bonds. Just like if you did the math for methane, CH4, you would see that it would form 2 bonds. But you don't even need to do the math to write these things once you realize how many bonds they have a tendency to make. PBr3. Phosphorus is in the same column as nitrogen. It is going to make 3 bonds. And remember, that's because phosphorus would look something like this. So these 3 electrons are available for sharing. There. And bromine is a halogen, so it's only ever going to make 1 bond. So what we can do is draw the phosphorus in the middle, draw 3 bromines coming from it. Now when you look at this, we have the right number of bonds, and if you did the math, it would say that you had to form 3 bonds, but the octet is not satisfied for these. What you have to look at for phosphorus, 2, 4, 6 electrons so far, so you have to put an unshared pair, so now you have 2, 4, 6, 8. Bromine only has 2 electrons around it so far, 2, so here's 4, here's 6, and here's 8. Make sure you draw them as pairs, and this bromine is going to be the same thing. All right, so you have 2, 4, 6, 8, and here 2, 4, 6, 8. So that's PBr3. Now the octet is satisfied for these. Phosphorus has 2, 4, 6, 8. The bromines are all the same, 2, 4, 6, 8. H2O2, hydrogen peroxide. Since oxygen forms 2 bonds, I am going to put that down first. All right, so now when you look at this oxygen on the left, there's 2 bonds. The oxygen on the right, there's 2 bonds. So now what we could do is fill in the hydrogen. And again, double check to see if you have to put in any unshared pair of electrons. So this oxygen on the left has 2, 4, there's 6, there's 8. The oxygen on the right, 2, 4, there's 6, there's 8. And again, if you did the math for it, you would see that it would form 3 bonds. It has 3 bonds. The octet is fulfilled. Remember, hydrogen only gets 1 bond, and because it can only hold those 2 electrons. When you're doing this, one of the things that people make mistakes on sometimes is remember the bond counts as 2 electrons. Because if you're going to draw out the Lewis structure for this, just for this left atom here, what you get is 6 electrons for this oxygen. You have that hydrogen that's supplying 1, and you get a bond formed there. That's why it counts as 2 electrons. Now, there are going to be times where you might have to use multiple bonds, so double or triple bonds. So CS2, for example, well, carbon forms 4 bonds because it has those 4 valence electrons that it can share. So for carbon, I'm only drawing 2 bonds right now because it only has 2 sulfurs to bond with. But there's a problem here. Carbon tends to make 4 bonds, right? Because you can think about it as looking like this. It has these 4 valence electrons, and they're available for sharing. And the sulfurs have 6 valence electrons, and because these 2 are available for sharing, so it would form 2 bonds. So what happens here is you would make a double bond. So now carbon, when you look at it, it has 2, 4, 6, carbon has its octet fulfilled. The sulfur here has 2, 4, so we have to draw in unshared pair of electrons on each sulfur. And you would end up getting that. Now, if you're going to draw this out, and let me rewrite these. So if we put the carbon in black and we drew it like this, and then we can put sulfur in red. And I'm going to draw this a certain way, where it has 6 valence electrons. So you're forming a bond here, and then these get shared. Now for the other sulfur on this side, I'm going to draw this a certain way. You get a bond formed here and a bond formed here. So you get this double bond, and here's a double bond. So each bond counts as 2 electrons, remember. So this is 2, and that's another 2. So that's why I said 2, 4, 6, 8. And here's 2, 4, 6, 8, because this is 2, here's another 2, and there's 6, and there's 8. So you might have to do some double or triple bonds sometimes. So for this one, FCN, carbon makes the most bonds, so I'm going to put that down first. I know the halogens only ever make 1 bond, right? So in this case, just the way it's organized here, I'm going to draw it like this, right? Because we have this going on, so you get a bond formed there, and that's this one on the left. I know I'm going to have to put in these unshared pair of electrons that I drew there. So now fluorine has 2, 4, 6, 8. Carbon only has 2 electrons right now, though. The only other element is nitrogen. Now nitrogen has a tendency to form 3 bonds. This pair is not available for sharing, but you can get a bond here, and a bond here. So I'm actually going to get a triple bond. Now when you look at this, carbon has 2, 4, 6, 8. So remember the bond counts as 2. Nitrogen so far has 2, 4, 6, but remember I have this unshared pair, so I have to put that back in. And now the octet is fulfilled for all these things. They all have that filled outermost energy level. So that is a general idea on how you draw Lewis structures for covalent molecules.